14.3, location and soil. Soil is a thin layer of rock fragments that covers the land. It's influenced by the latitude, the altitude, and the topography. Remember, latitude is how far from the equator it is. Altitude is how high up from sea level it is. And topography is mountains or rivers, valleys, plains. Good soil contains plant nutrients like nitrogen. It can hold water and gives plants a firm place to grow. So plants won't grow without good soil. This tree is growing in the cracks of a rock, so there must be enough soil in those cracks to provide nutrients to this tree for it to have grown so large. Particles of soil are composed of 4 different things. From smallest to largest particle size, clay, there's silt, sand, and gravel. So I've given you a little scale here. Silt, the second largest particle, is just a speck on this scale. All right, very, very small. Clay is invisible. Now, clay we think of as clumps. However, if you were to totally dry out clay, it's holding a little bit of water. If you were to dry it out, it would be a very, very fine powder. So next up was silt, a little bit larger. Sand is quite a bit larger. You can actually see a grain of sand. And then gravel, of course, has varying different particle sizes. Soil doesn't always contain all 4 types of particles, but it has some combination of these 4. Humus is part of soil that contains broken down plant fibers, soil particles, and decayed organisms, whether those are plants or animals. It also contains living organisms like bacteria and fungi. So mushrooms. These are our decomposers. Humus is produced by these decomposers like earthworms. And you can see in this image that humus is the top layer. So it would be like our top soil, if you will. Then we get the silt and clay often mixed together. And then we get some sand mixed with gravel, and then parent rock is like really large rocks underneath the ground. So gravel is small, parent rocks would be those larger ones. And again, sand is filling the space in between here. Soil crumbs are particles of humus that have clumped together. This is really good for soil because the spaces allow roots to grow and spread. The spaces also allow air into the soil. It helps to keep the soil moist, but the spaces allow excess water to drain. And it's less likely to be blown away in the wind than smaller soil particles because they are larger, heavier clumps. So this is an investigation in your textbook, and I just wanted to point out a couple things here. So if you don't want to listen to me read it, you could look on page 279 yourself. Otherwise, the characteristics and depth of soil vary from place to place. The climate and vegetation in an area are the main factors that determine the soil's quality and depth. The figure here, which I put on the next slide, shows the soil profiles of 3 major soil types found in North America. You can see a soil profile if you carefully dig a hole with straight sides and you look at it from the side. You can see the layers. The horizontal layers are called horizons. The top layer, horizon A, is called topsoil. It consists of rich, dark colored soil that contains humus and very small rock fragments. The next layer is lighter because it contains very little humus. It contains clay, silt, or sand, plus minerals that have been leached from the top layer. Leached means slowly moved down by water below. The bottom layer is most similar to parent rock. All right, so we see here A was topsoil and mostly humus and some very small rocks. B was our clay, silt, sand. And then C was parent rocks, so larger rocks and sand. So we see grassland soil, we see forest soil, and we see desert soil here. And we can compare their different horizons. So grassland soil, for instance, occurs naturally in areas with lower rainfall. The surface or topsoil is deep and supports most of that root growth for the plants. In B, forest soil here, forest soil develops in areas with more rain. The rain carries minerals deeper beneath the surface of the soil into this subsoil, so B horizon. In forest, the layer of topsoil is not as thick. So to get to these minerals, the roots must grow further down. Deserts have limited plant growth due to low levels of precipitation, so they don't have much humus on the top layer because they don't have much decaying plant matter. So there's a very thin layer of topsoil, if any. Take a look at page 280, number 1, 2, and 3 if you're looking for some practice with this material.